Alright, and welcome to Graphing Exponential Functions. Now, I was a little bit torn on how to teach y'all to do this, but I think teaching you the right way to do this, even if it may seem a little difficult at first, I think that's going to be the way that's obviously more beneficial for you. So really bear with me through the first 2/3 of this problem, but if you can make it through that, I think you'll have a more solid understanding of this. So we want to graph f of x equals 4 parentheses 2 to the power of x minus 4. And this is, of course, what we call an exponential function because our variable x is in the exponent. The easiest way to graph these is to literally just pick 3 points. And once you use those 3 points, or 3 x values, you can plug in those 3 x values, find your 3 points, and then graph your function through there. So we're going to always choose -1, 0, and 1. We're going to use 3 very easy numbers. Now, let's go ahead and test these out. The first one is f of -1, which will equal 4 parentheses 2 to the power of -1 minus 4. Now, a lot of y'all might not know this property, so let me just show y'all some examples. If I were to take 3 to the -1, well, you can imagine 3 is really like saying 3 over 1. Anything with a negative exponent, you make it positive by taking it to the opposite side of the fraction bar. So 3 to the -1, I can make this 3 to the +1 by simply bringing it down below. And then, of course, you just have an implicit 1 on top. Okay, and 1 over 3 to the power of 1, well, 3 to the power of 1 is just 3. So let's try this one more time. What if I had 4 to the power of -1? Well, I would write it as a fraction. I would take that -1, I would bring it down to the bottom, and I would have 1 over 4 to the power of 1, which is, of course, 1 over 4. Similarly, we can write this as 4 to the 2 to the power of -1 just becomes 1 over 2 minus 4. So this is just a little trick that you are going to have to learn at this current stage, but it'll be involved in all of these. Now I'm going to pause the video and clean this up just a little bit. Okay, so now what we have is 4 times 1/2. Well, really this is 4 over 1. And we know that when we multiply fractions, we have top times top, which is 4 over bottom times bottom, which is 2 minus 4. And 4 divided by 2 is 2 minus 4, which is -2. So our very first point is at -1, comma, -2. All right, finish taking the notes here, and let's move on to f of 0. Okay, here we have our second property. When we look at f of 0, we're going to plug in 0 into the x, so I have 4 times 2 to the power of 0 minus 4. Well, what is any number to the power of 0? So for example, x to the power of 0, we actually have a rule here. Anything to the power of 0 is always equal to 1. So for example, 3 to the power of 3 to the power of 0 is 1. What about 100 to the power of 0? That's also 1. Literally anything, I could write something crazy like this, 3x squared divided by the square root of 50 to the power of 0 will equal 1. Okay, so what happens here? Well, 2 to the power of 0 is equal to 1, and we can do 4 times 1, which is 4, minus 4, which of course is 0. So all we're doing is just working down there on the right-hand side. So f of 0 is 0. And this brings us to our last x value of 1. Okay, so now let's test this out. F of 1 is equal to 4 times 2 to the power of 1 minus 4. Okay, so let's see what we get here. We have, well, anything to the power of 1 just doesn't change. So this is literally 4 times 2 minus 4. Well, 4 times 2 is 8 minus 4, and of course 8 minus 4 is 4. So let's say f of 1 is equal to 4. At this point, I can plot these 3 points. Let's see, we went to the left 1 and down 2. And right over here, we have a point at 0, 0, and we have a point at 1, 1, 2, 3, 4. Now, here's the last thing. Whatever constant you have being added or subtracted, this is your horizontal asymptote. So -4, I can come down to, let's see here, 1, 2, 3, 4, and I'm going to draw this horizontal line, this horizontal dashed line, and essentially my function gets really close to that, and then it'll start to leave to start to hit these points, and the rate of growth increases and increases. And exponential functions, they increase very quickly. That's where you get this curve where they're increasing very slowly, and then all of a sudden they increase very quickly. All right. Now I know that I hit you with two especially confusing new rules, so let's go ahead and look at one more example. Okay, for example 2, we have graph f of x equals 2 1/2 to the power of x minus 1. Notice that 1/2 is actually less than 1. This indicates that we're actually going to have exponential decay. That means that from the left to right, this is actually going to be a decreasing function. Now, of course, the easy values that we always want to do are -1, 0, and 1. Okay, so let's take a look here. I have f of -1 is equal to 2 to the 1 over 2 to the power of -1 minus 6. Now, what's the rule here? Well, whenever you have a fraction raised up to a power, you can actually take both of the numbers in the fraction and raise them up to that power. So this is 1 to the -1 over 2 to the -1 minus 6. And remember, in order to change these powers from negative to positive, we take them and we flip them to the other side of the fraction. So this 1 to the -1 goes to the bottom, this 2 to the -1 goes to the top, and we can rewrite this as 2 times 2 to the +1 over 1 to the +1 minus 6. Well, 2 to the power of 1 is just 2, 1 to the power of 1 is just 1 minus 6. And what is 2 divided by 1? Well, 2 divided by 1 is simply 2 minus 6. I see that I have 2 times 2, which is 4 minus 6, which is, of course, -2. So, -1, comma, -2. I go to the left 1 and down 1, 2, and put my very first point. I would encourage you to pause the video, finish taking notes, really think about this principle right here. Whenever you have a negative exponent, you simply take that number and move it to the other side of the fraction. If it's on top, it goes to the bottom. If it's on the bottom, it goes to the top, and your exponent becomes positive. All right, let's look at our second point at 0. Okay, we're going to take a look at f of 0, which is equal to 2 times 1 over 2 to the 0th power minus 6. Well, what did we learn in our last video? Anything to the 0 power is equal to 1. So 1/2 to the 0 power is equal to 1 minus 6. And here 2 times 1 is 2 minus 6, which is -4. So we'll say, okay, f of 0 is at -4. Alright, so I'll go to 0 and I go down 1, 2, 3, 4, put my point. And this brings us to our very last point where x is equal to 1. Let's go ahead and solve that. Okay, here we will have f of 1 is equal to 2 times 1 over 2 to the power of 1 minus 6. Now, notice anything to the power of 1 just does not change. So 1/2 to the power of 1 is simply 1/2. Okay, I can change 2 into fraction, 2 over 1. And I have top times top. 2 times 1 is 2 over bottom times bottom. 1 times 2 is 2 minus 6. 2 divided by 2 is 1 minus 6, which is -5. Okay, so f of 1 is equal to -5. So I go to the right 1 and down 1, 2, 3, 4, 5. Okay, now notice here we have a -6, which means that our horizontal asymptote has shifted down 6. So here was -5. So here's -6. Sorry, it took me a second to think about this. But so our horizontal asymptote, remember that constant will be the horizontal asymptote. So we have this dashed line that's here at -6 at the bottom of this graph. And so essentially, since we have exponential decay, from the left to the right, we decrease very quickly. We go through our 3 points. And then right as we start to hit this dashed line, we flatten out and we never touch that dashed line. We just get closer and closer to that horizontal asymptote. And one more time, you always get your horizontal asymptote from that constant right there. Since it was -6, we have a horizontal asymptote where y is equal to -6. Alright, I hope that these examples helped, and I will see you in our next video.